Question 7. Part A says, for y between minus pi over 2 and pi over 2, sketch the graph of y equals g of x, where g of x is equal to arcsine of x. X is between 1 and minus 1. Arcsine can be written as sin to the minus 1 of x. And you need to know that this is the inverse of sine x. The sine x graph looks like this, between 2 pi and minus 2 pi. To find the inverse of sine, to get arcsine, we need to reflect this in the line y equals x. We're only interested in the region between minus pi over 2 and pi over 2, which is this region here. So the sine graph between this region looks like this. We need to remember, because arcsine is the inverse of sine, we can find the inverse by drawing a reflection in the line y equals x. This goes with any functions or any graphs. You can find the inverse by drawing the reflection in the line y equals x. So reflecting the sine graph in the line gives us this curve, which is our arcsine. So the green graph is the answer, so it might help to draw it separately and label. Remember that the domain for the original graph or the original function becomes the range for the inverse, and the range of the original becomes the domain for the inverse. Part B says, find the exact value of x for which free g of x plus 1 plus pi equals 0. From part A, we already know that g of x is equal to arcsine x, which I prefer to write as sin to the minus 1 of x. G of x plus 1 is a transformation of this, so it's a translation in the x-axis by minus 1, and looks like sin to the minus 1 of x plus 1. So free g of x plus 1 plus pi equals 0 becomes free sin to the minus 1 of x plus 1 plus pi equals 0. We can move pi to the other side by taking it away and dividing by the free to get sin to the minus 1 of x plus 1 equals minus pi over 3. Applying sin to both sides will get rid of this, so we will have x plus 1 equals sin of minus pi over 3, and using your calculator we can find this equal to minus root 3 over 2. For the final answer, we move the 1 to the other side, so x equals minus root 3 over 2 minus 1.